Assalamualaikum and good morning to all. At the end of this video, students should be able to explain the continuity and to compute the continuity of a function at a point. Okay, so for now, we will learn about the last subtopic, which is continuity. Okay. So first of all, we can refer to the diagram. Okay, so if we have a graph, okay, here you can draw the graph without lifting your pen. Okay, so we can say that the function is continuous at every point here. So continuity ini bermaksud dia tak putus, dia bersambung. Okay, so second diagram. Okay, so kita lukis yang warna biru ni, and then without lifting your pen, okay, kita boleh sambung lukis yang warna merah. Okay, ini kita boleh cakap dia continuous. Next, for diagram C, okay, let's say this is the point A. Okay, if we want to draw the graph, okay, we draw the blue color here, and then kita kena angkat pen, kita kena draw the red color. So, dia discontinuous at x equal to A. Maksudnya dekat A ni dia putus. Nah, discontinuous, tidak bersambung, tidak selanjar. Ya? Okay, and the same thing for part D. Dia putus dekat sini kan. So, discontinuous here. Nah? Okay. Next. Definition of continuity at a point x equal to C. Okay. The function is continuous if dia satisfies all the three conditions. So, awak kena hafal. Yang tiga ni, kena hafal. Okay. First, we check FC. Okay, katalah saya buat graf dia macam ni contohnya. So, ini adalah titik yang kita nak check. Okay. Dan sini C lah. Contohnya sini C. Okay. So, kita kena cari C ni. C tu wujud ke tak? Itu maksudnya FC axis. Next, limit fx as x approaches C axis. Ataupun kita kena tahu limit C from right must be equal to limit C from left. Maksudnya from right dengan from left dia menuju ke arah satu jawapan yang sama. Ya? Maksudnya limit C from right equal to limit C from left. Dan for C, okay, the third condition, limit fx as x approaches C must be equal to FC. Maksudnya, okay, maksudnya macam ni. Limit from right equal to limit from left and equal to that at that point, equal to the value when x equal to C. Kiri, kanan dan tempat tu jawapan dia sama. Barulah dia akan menutup tempat tu. Faham tak? Maksudnya dia tak putus. Okay. So, kalau dia satisfies all the three conditions tu, barulah kita kata dia tu continuous at that point. Ya? Okay, yang tu awak kena hafal tiga tu ya. Okay. So, next. Find the interval for x which f is continuous. So, to find the continuous interval, kita akan cari dia punya domain sahaja. Nah? Okay. So, for first one, ini namanya linear function. So, for linear function, domain is negative infinity until infinity. Therefore, f is continuous at negative infinity, infinity. Okay, and part B, okay, we have square root of 2x minus 5. So to find the domain, we set the function inside the set is greater equal to 0. So we will get x greater equal to 5 over 2. Or we can write 5 over 2 until infinity. So this is the domain. So we can say that f is continuous at 5 over 2 infinity. Okay, function akan continuous dalam dia punya domain. So kalau bukan domain dia, tak payah carilah, memang dia tak ada, which is discontinuous. Okay, next. Ini under reciprocal function. Okay, so kita tengok yang kat bawah ni cannot be 0. Sorry, x minus 2 cannot be 0. So x, for this case, cannot be 2. So domain of f will be negative infinity until 2 union to infinity. Okay, therefore f is continuous at negative infinity to union to infinity. Boleh? Function akan continuous dekat dia punya domain. Okay, next part D. Okay, we have modulus 3x minus 7 plus 2. Okay, so ini under absolute values of modulus function. So, domain is all real numbers. Okay, so negative infinity until infinity. Therefore, f is continuous at negative infinity, infinity. Okay, so ini in general. Kita cari dia punya domain sahaja. Okay, next is the continuity at point x equal, okay, x equal to 1, 2 and 3. Okay, so now kita akan check one by one. So first kita kena check when x equal to 1. Okay, x equal to 1. Okay, awak kena hafal 3 condition tu lah. Okay, so condition yang pertama apa? First, f c axis. Second, we check limit x approaches c positive, okay, must be equal to limit x approaches c negative. So in general, we can find limit fx as x approaches c, okay, is what number? And third condition, we compare fc must be equal to limit fx as x approaches c for continuous function. So yang ni dia kena sama dua-dua tu baru dia continuous. Boleh? So tolong hafal yang 3 condition ni, wajib hafal. Okay, so now we will check when x equal to 1. Okay, so part A. Okay, first condition, f1 equal to, okay, tengok dekat graf. f1, 1 is here. f1, okay, dia dan circle kat sini. So f1 equal to 1, exists, ada. Okay, so we move to the next condition. We check limit fx as x approaches 1 from positive. Okay, 1 from positive is here. Okay, so the answer is 1. And next, limit x approaches 1 negative, okay, 1 negative is from the left of 1. So, mana graf dia? Ni, graf yang atas ni. So, jawapan dia is 2. Okay. So, from here, limit fx as x approaches 1 positive is not equal to limit fx as x approaches 1 negative. So, we can conclude that limit fx as x approaches 1 in general does not exist. Therefore, okay, kita tak perlu check dah. Kita tak perlu check dah. Third condition tu tak perlu sebab kita dah kantoi dah yang second condition. Dah tak jadi dah. Nah, therefore fx is not continuous at x equal to 1. Nah, kena tulis dia punya conclusion. Okay, and the next one, okay, kita akan check the continuity when x equal to 2. Okay, so, first, f2 equal to 2 means exist. Ada jawapan. Okay, next, limit part B. The second condition, limit x approaches 2 positive. Okay, refer the diagram. 2 positive on the ini 2 positive kan. 2 positive meaning kita akan tengok from the right of 2. So the answer is 1. Salah tulis. Fx equal to 1. Okay, next. Limit x approaches 2 negative. Okay, refer the diagram. 2 negative bermaksud dari kiri 2. So, jawapan dia 1. Okay, tengok graf tu. Jawapan dia 1. Okay, next. We can conclude that, okay, limit fx x approaches 2 positive equal to limit fx as x approaches 2 negative equal to 1. Sama ni, dua-dua ni sama. Okay, therefore, limit fx as x approaches 2 in general equal to 1. Okay, so kita ada dua dah. F2 is 2. Limit when x approaches 2 is 1. Okay, and the third condition, part C, okay, we compare. F2 is 2. Limit is 1. So, not equal to limit fx as x approaches 2. Therefore, fx is not continuous at x equal to 2. Kenapa? Sebab dua-dua tu tak sama. Okay, A dengan B tu jawapan dia tak sama. Okay, and next one. Okay, part number x equal to 3. Okay, cuba buat check. X equal to 3. Okay, cuba check F3 berapa. Okay, cuba check. Okay, agak-agak F3 berapa, limit berapa, and the last one, we try to compare. Okay, x equal to 3. Okay, first, F3 equal to 2. Axis. Second, limit fx x approaches 3 positive equal to Okay, 3 positive. Okay, yang sini kan? 2. Limit fx, x approaches 3 negative is also 2. So, limit fx, x approaches 3 in general exists and the answer is 2. Kenapa? Sebab kiri dan kanan dia sama. Okay. And part C, the third condition, f3 is 2. Limit is also 2. So we can write f3 equal to limit fx, x approaches 3 equal to 2. Therefore, fx is continuous at x equal to 3. Example number 20 on page 20. If fx is continuous for all values of x, find the constant a. Okay. So kita ada piecewise function. Okay, dan dia berubah dekat 1. Less equal to 1. The function is ax plus 5. And more than 1, the function is x squared minus 1. Okay. Dan dia ada word is continuous for all values of x. So, tiga condition tu maksudnya dia satisfy. Boleh? Okay. So, kita boleh tulis apa? FC equal to limit fx, x approaches C positif dan akan sama juga dengan limit fx when x approaches C negatif. Okay, ada 3 benda yang kita boleh samakan. Tapi kita pilih 2 je lah for this case. Untuk kira ni kita pilih 2 je. Nah, so saya akan pilih these 2 function tu lah. Nah, okay, so saya akan buat limit fx. Okay, for now C is 1. Kita akan pilih dekat tempat yang function kita ni berubah. Nah, kenapa? Sebab dia ada perubahan kiri dan kanan dia. Ya. Okay, so kita akan ambil limit x approaches 1 positive first. Okay, for 1 positive, we will use x squared minus 1. Okay, and for limit x approaches 1 negative, kita akan guna apa? Kita akan guna ax plus 5. Okay, so kalau kita cari kat sini, kita akan dapat equal to 1 squared minus 1 equal to 0. And for the left part, we have a times 1 plus 5. And then we equate both, we will get a plus 5 equal to 0. So, A equal to negative 5. Kita samakan dua-dua tu. Ya? Okay, next. Example number 21. Function f is defined as this. Okay, so saya transfer dia nak bagi nampak. So, saya akan tulis 2, 3. Less equal to 2. 9 minus x squared. 2 until 3, the function is p exponent x. And more than 3, the function is ln x minus 3. Okay, ada berapa nombor yang sesuai awak boleh check? Ada 2. Number 2 and number 3. Ada dua tempat yang sesuai sebab dekat tempat tu berlakunya perubahan function. Boleh? Okey. Dia kata kat sini, tengok dia punya soalan dia kata limit fx as x approaches to axis. Maksudnya sekarang ni kita akan refer dekat 2. Kenapa tak boleh refer dekat 3? Sebab dia tak cakap apa-apa dekat 3. Dia tak kata continuous, dia tak kata limit exist, tak ada info. Nah, so kita akan guna when x equal to 2. Given limit fx x approaches to axis. Therefore, we know that limit fx x approaches to positive must be equal to limit fx x approaches to negative. Must be. Nah, kenapa? Sebab dia kata axis. Okay. So, limit for x approaches to positive, we will use to positive p exponent x. Okay, and equal to limit for x approaches to negative from left, we will use 9 minus x squared. Okay, we substitute p exponent 2 equal to 9 minus 2 squared. So, p exponent 2 equal to 9 minus 4 is 5. Therefore, p equal to 5 over exponent square. So, kita boleh stop kat sini lah. So, tak perlu tukar kepada decimal point. Nah, ini adalah jawapan yang paling tepat. Okay, and the last example on page 21, example number 22. Okay, the function is defined by the given piecewise function. Find limit fx as x approaches 1 from negative. 1 from negative. Okay, saya lukis gini nak bagi nampak sikit. So, we have 1 less than 1. The function is 1 plus exponent x. At 1, okay, exactly 1 ni, tepat-tepat atas 1 tu, function dia 3. Dan, more than 1, ke sana tu, function dia 2 plus e minus x. Okay, first part, limit x approaches 1 negative. For 1 negative, we will use 1 plus exponent x. Okay, so equal to 1 plus exponent 1 or 1 plus e. The next one, limit x approaches 1 positive. For 1 positive, tengok function yang dekat kanan 1 tu, dekat sebelah kanan dia. Yeah? So, we have 2 plus e minus x. And we substitute. So, we will get 2 plus e minus 1 or 1 plus e. Okay. And next, hence, discuss the continuity at x equal to 1. Okay. So, from the previous calculation, we can say that limit x approaches 1 negative equal to limit fx as x approaches 1 positive equal to 1 plus e. Okay. So, in general, limit fx x approaches 1 exists and the answer is 1 plus e. Okay, ini in general. Okay, for continuity, okay, bukan satu ni je kita kena check. Ada satu lagi. First condition kita tak check lagi. Okay, so kita akan check F1. Tepat-tepat dekat satu tu. So F1 equal to, kita tengok balik F1, the answer is 3. Tepat-tepat dekat 1, x equal to 1, the answer is 3. Okay, next kita compare. Limit fx x approaches 1 sama ke tak dengan F1? Yes, not equal to F1. Tak sama. Therefore, fx is not continuous or discontinuous at x equal to 1. Okay, boleh ke? So, untuk continuity, you need to remember the 3 conditions. First, kita akan check FC. C tu tempat yang kita nak check lah, x equal to C. FC exists or not. Next, second condition, limit C from positive, C from negative, sama ke tak? Kalau tak sama, discontinuous. Kalau sama, check. FC sama tak dengan limit? So, kalau sama, barulah kita buat conclusion, dia tu continuous. Kalau ada satu je yang tak satisfy, terus discontinuous. Boleh? Okay, so before kita stop, okay, sebelum ni awak ada belajar limit at number when x approaches number lah. Okay, so for limit at number, first we substitute directly. Okay, so kalau awak dapat number ataupun dapat infinity, you need to check lah, positive infinity ke negative infinity. Yang ni nak check dia macam mana? Kita kena substitute one number, okay, by referring dia punya sign. Kalau positif, ambil yang sebelah kanan. Kalau sign dia, let's say 2 positif, ambil 2 point something. Kalau 2 negatif, ambil 1 point something. Macam tu lah. Okay, and then sometimes you akan dapat 0 over 0. 0 over 0 under undetermined. So, yang ni awak boleh sama ada factorize or times conjugate. Okay, next we have limit at infinity. X approaches positive, negative, infinity. Okay, first we substitute directly. Okay, maybe you will get number, maybe you will get infinity, but sometimes you will get infinity over infinity. So, for infinity over infinity, kita akan factorize numerator and denominator. And please take note that third x squared can be positive x if your x approaches positive infinity. And okay, can be negative x if your x approaches negative infinity. Boleh kan? Okay. Dan limit at number ni, limit at number, okay, will be used for vertical asymptote. Limit at infinity, kita akan apply untuk guna apa? Untuk cari horizontal asymptote. Okay, and the last one under continuity. Okay, hafal 3 benda. First, FC. Second, limit fx x approaches C axis. So nak tahu dia axis ke tak, kita check dua lah. X C positive, X approaches C negative. And third condition, we compare. FC equal to limit fx sx approaches C. Okay? So kalau dia satisfy tiga-tiga tu, dia akan continuous. Boleh? Kalau ada salah satu yang tak boleh cari ataupun bila kita compare tak sama, dia discontinuous or not continuous. Okay, so kita jumpa lagi untuk tajuk yang seterusnya. Thank you very much.